The broadcast is now starting. All attendees are in listen-only mode.
Good afternoon, and welcome to the Aculon NanoClear webinar. We're going to be talking about some of the general features of webinar, getting into some case studies, and talking about the features and benefits you can expect and cost savings with utilizing the NanoClear fluxophobic stencil treatment. So let's get started. My name is Mario Gattuso. I am the Senior Business Development Manager here at Aculon. I manage our electronics business portfolio, which includes NanoProof and NanoClear, which is what we're going to be discussing today. First of all, if you are in the Bay Area or nearby, we're going to be exhibiting at PCB West next week. That's September 12th in Santa Clara. Again, we're going to be at PCB West next week, September 12th, 2018, booth 603. If you're watching a recording of this webinar in the future, keep in mind this is only relevant for people who are watching the live recording. Today's presentation, we're going to be discussing the NanoCoating benefits to treating your stencil. We're going to review the cost and payback calculator. We're going to go over documented performance improvements, including spray-on coatings versus NanoClear. We're going to discuss the Aperture sidewall coating of NanoClear, and then also get into best practices for cleaning and durability. So to go over Aculon quickly, Aculon is a leading provider of surface modification technologies. We focus on development and distribution of technologies which modify a broad variety of surfaces, mainly focusing on metals, glass, and polymeric substrates. Obviously, in this case, with stencils, we're talking about treatment for metal. These treatments include functionality surrounding hydrophobicity, oleophobicity, hydrophilicity, and also adhesion-promoting treatments. Like NanoClear, a perfect example, all of our treatments are extremely thin, easy to apply, very robust, and require minimal equipment. Our main focus is the electronics, oil and gas, and specialty industries, and our business model is to produce and sell chemistry. We're based in San Diego, and we have worldwide distribution. We distribute in Europe via our partner Caplink. ASM and DEC also distribute NanoClear globally, and then we have multiple distributors in Asia. And then we can also source the material directly from our facility here in California. So for those of you who are new to NanoCoatings for stencils, what is a NanoCoating? It's a extremely thin flux repellent film that's applied to the bottom side, and most importantly, it's applied to the aperture walls of stencils. It improves the quality via higher yields and better transfer effectiveness. It will boost your productivity via less underwiping and less downtime for paper changes. And it's also going to significantly reduce your costs. There's going to be less rework required and lower consumables consumption. NanoClear is a SAMP molecule, or a self-assembling monolayer phosphonate. So it's a very robust treatment. It very aggressively bonds to the metal, but it only bonds to the metal, it does not bond to itself. So it does not cross-link, it does not form multiple layers. And so you get a very reliable coating in the range of 1 to 4 nanometers thick, typically about 2.5 nanometers in thickness across the entire metal stencil, and including within the aperture walls, you're going to get a perfectly even coating. So to go over some of the previous technologies that have kind of been a step change for stencil printing, laser cut apertures were an improvement over the previous chemically etched apertures. Specialty alloys were introduced, which improved over generic stainless steel, and then machined and welded multi-level steps improved over chemically etched single steps. And all these technologies have provided a step change in performance, but also have added a step change in cost. Whereas the NanoClear NanoCoating has always been extremely affordable and will continue to be affordable. To get into some of the print performance improvements, here's an example of a 0.4 millimeter QFN, and you can very clearly see on the left, without NanoClear, it's a sloppy print. The paste is almost bridged nearly at the top there, and on the right you can see that the paste definition is almost perfect. It's almost perfectly aligned on those solder pads. And then I did want to note that for all of these pictures we're looking at, you're looking at a very controlled study. So a single stencil with duplicate apertures on each side was coated down the middle, or down one side. So one side is non-coated, the other side is coated. And so both of these pictures were the result of the same print on the same stencil, just one side was coated, one side was not. Again, here you can see on the left, that there is sloppy definition on the solder. The left side required a cleaning after 3 prints with wet dry wipe and a cleaning after 6 prints with wet dry back wipe. Whereas the NanoClear side, you can clearly see the definition is significantly improved and the cleaning frequency was reduced to once every 5 prints and then once every 10 prints respectively. There are major name brand users, some of which implement them across every single stencil they use. NanoClear is utilized and recognized at companies like Intel, IBM, Qualcomm, Flex, Foxconn, ASM, Roland, and that's just to name a few. There are multiple users of Aculon's NanoClear. NanoClear has been around since 2014. It's well respected. It's earned several industry awards and has been featured in several industry publications over the years. So some of the key benefits you're going to expect to achieve with NanoClear is improvements in quality, productivity, and cost reduction, regardless of what type of component you're using. So it's just not high density components where you're getting an improvement. You're getting improvements across high, medium, and low density stencils. You're also getting improvement on almost every single stencil with regards to component mix. So fine component pitch mixes of 0.5 millimeters or less, you're getting a drastic improvement across the board. With a mix of fine and coarse pitch components, you're getting a very good improvement. And even with large pitch component stencils, you're still getting a good improvement. And again, depending on the component type, you can see across the board when it comes to quality, productivity, cost reduction, you're going to see improvements. So essentially what this is getting at is that NanoCoatings are not just for fine pitch stencils anymore. So initially, a lot of thinking was that only extremely difficult stencils would benefit from a NanoCoating. And what we've seen is that every single stencil can benefit from a NanoCoating. So you may not need the NanoCoating to enable printing as you would with some very difficult stencils, but you're going to see improvements in quality and you're going to see cost savings as well across the board. Again, here is an example of the improvement you can see with a NanoClear coated stencil. This is the same stencil, half's treated, half is not treated. This is 10 prints and 1 wipe, and the flux was treated with a UV dye. So after the 10 prints and the wipe, the stencil was put under a UV light, and you can see the untreated stencil has smeared paste all across the bottom of the stencil, and the nano-coated side is significantly cleaner. So when you go to do your next print, that untreated side is going to be transferring a sloppy flux from the bottom side onto your board, and is going to lead to a low quality print, and the flux is going to be more prone to wick along the bottom side. So in order to help you quantify the value you're getting out of NanoClear on your stencils, we created a very simple to use cost and savings payback calculator. It's easy to use. It is transferable to any currency. All the calculations are transparent, and it gets you a return on your investment in addition to process improvements as well. So let's look at that. So first, in order to get into your operations cost savings, there's a section where you can enter your own data on your costs of a simple rework based on the time required, your label rates, etc. The cost of a complex rework, you can enter data on the cost of your wiper paper, the cost of your wiper solvent. So then you can get into your operating cost savings and additional uptime. So you can essentially enter a before and after on your wipe frequency before and after, your first pass yield before and after, your defects before and after, and the number of parts you have to rework. And so what it allows you to calculate is the payback, or the number of prints. And so this is an actual chart that one of our customers filled out, and as you can see, after simply 43 prints, the cost of NanoClear is paid for itself, and then from 43 prints on, all those savings go direct to that customer's bottom line. So here we have some documented performance improvements from a customer. This customer reported SPI yields were boosted from 60 to 75%. On a 0.4 millimeter QFN, the height was reduced from 120% of stencil thickness to 97% of stencil thickness, and the transfer efficiency was reduced from 150% to 125%. So this tells us that the NanoClear is assisting with providing a higher quality print, and the amount of material and the shape of the material is more in line with the actual size of the aperture. Question we get all the time is, does the NanoCoating coat the inside of the apertures? And people say, well, you're only wiping the top side, so how is it coating inside the apertures? So the NanoClear coating is contained within a solvent that is incredibly free-flowing, and the NanoClear coating itself, the SAMP, is highly reactive to the oxide layer on metals. And so when that NanoCoating flows through the apertures, it is most definitely fully and completely coating the inside of the apertures. The only reason you actually technically have to wipe NanoClear onto the stencil is to force contact time of the solvent containing the NanoClear actives with the stencil. If you were not to wipe the stencil, the coating actually becomes autophobic to itself as it reacts, and so you would find that the coating would start to bead up as the stencil repelled itself, and you wouldn't get a full reaction. But by wiping and by forcing the material through the aperture, you're ensuring that full coverage inside of the apertures. So in order to prove that it's in the apertures, and because it's so thin and it's difficult to see at only 2 nanometers thick, we utilized a technique called transmission electron microscopy. And so here you can see a nano-coated stencil. The stainless steel is on the bottom, and there's a CR layer which has been added so that you can distinguish between the coating between the CR and the stainless steel. And you can see a nice light gray layer about 2.5 nanometers thick, which is the NanoClear on this stencil. So confirming that it is coating the aperture. Again, this is a sidewall after 15,000 prints. Still, you can see that 2 to 2.5 nanometer thick layer of light gray on top of the stainless steel, proving that after 15,000 prints of flux moving back and forth through the aperture, that the NanoClear is still there, it's still functional and doing its job. So we get a lot of questions for people looking, should they pick NanoClear, the wipe-on coating, or should they pick the spray coating? And, well, we can see the spray coating, so we know it's there. So, yeah, it is nice to see a spray coating there. You can visually look at it, but remember, just because you can look and see that the coating's there doesn't necessarily mean that it's functional. So we do get many reports from people that the spray coating loses its functionality and the stencil starts to either perform poorly or as though it was a non-coated stencil, even though they look at the stencil and that spray-coated stencil is still on the stencil. Whereas NanoClear, you may not be able to see it, but there's an extremely easy quantitative test. You take the NanoClear test pen, or you can even drop some droplets of water on the stencil and see if they bead up. If it beads up, you can know for sure that the stencil is functional and properly coated with NanoClear. If it's not, all you need to do is take 5 minutes, recoat that stencil, and you're not throwing a stencil in the trash like you would need to do with a damaged spray coating. Some spray-on issues that have come up over the last year or two, now that that's been on the market for a few years. We have numerous customer reports of spray-on coatings cracking, chipping, and flaking off. And so this leads to many problems. If a stencil with a spray-on coating has cracked, if the coating is chipped and flaked off, it's unusable and it needs to be thrown away. There's no way to rework that stencil. That stencil can't be used uncoated because most likely you've changed the aperture sizes to accommodate that coating. So you're essentially out an expensive stencil and a even more expensive spray-on coating. Also, there's no QC check to confirm whether the coating is cracked or chipping or flaking off. So you don't know when that stencil is starting to misprint, when it's starting to have odd-sized apertures because the coating is cracking off inside of the aperture, and you're going to get contaminated and poorly performing paste as well. Another issue with the spray-on coatings that's also inconvenient is the need to only do it at one of the suppliers, and you also have to redesign your stencil to accommodate the thick coating. In addition, a spray process is inherently difficult to control the thickness. So despite what someone might tell you, it's going to be extremely difficult, and you're going to have poor quality control of your aperture sizes and potentially inconsistent results and variation from aperture to aperture. In addition, before the coating is able to cure, you're most likely going to get slumping and a thinner coverage of coating over the edge walls of the aperture. And then, as mentioned before, we also have several customers who've come back to us reporting that the spray-on coatings cease to function after multiple prints, even though the coating is technically still visible. So a visible coating is definitely not a good proxy to check for the functionality. You just know that there's a yellow coating there. You don't necessarily know that the coating is serving its purpose. So NanoClear is a monolayer. It is never going to crack, flake, or chip. It is literally impossible due to the nature of this coating. So your paste will never be contaminated, and you will never need to discard a stencil due to NanoClear. If you do determine, based on the simple check of either using a NanoClear test pen or dropping droplets of water on the stencil to confirm repellency, all you need to do is spend 5 minutes recoating that stencil, and you have a new, perfectly functioning NanoClear coated stencil again. But I think you'll find if you follow our recommended procedures for cleaning and how to treat your stencil, that most likely the NanoClear is going to last the lifetime of your stencil, and it is a permanent treatment, so you will never need to recoat it. Also, NanoClear never requires a stencil redesign. So getting into some of the best practices for durability, based on 5 years of production and multiple research projects, we found that it's extremely critical that a soft and non-abrasive under stencil wiper paper, such as the EcoRoll or HyperClean, is utilized. You kind of think of it as like using a soft scrub brush for your Teflon cooking pan versus an abrasive scrub that you might use for a stainless steel pot or a hard steel pan. You certainly wouldn't want to use that on a Teflon pan, and you don't need to use it. All you need is just a paper towel or a soft cloth on your Teflon pan, and it's the exact same thing with the stencil. Stencil is repellent. It doesn't need an aggressive cleaner or aggressive white paper. So use something soft and non-abrasive, and you're going to get a clean stencil, and you're going to have a nice long-lasting NanoClear coating. Also, it's recommended use a solvent wipe rather than a dry wipe, and engineered solvents are always best for lead-free, no-clean paste. In addition, and this is a critical requirement, is you must utilize pH neutral cleaners or organic based cleaners. So a caustic or a high pH, anything with 9.5 and above, is going to be damaging in NanoClear. This is a known thing, so it is a requirement. If you're using a NanoClear treated stencil, you must use a pH neutral cleaner. Also, one of the functions of NanoClear is allowing you to reduce your under stencil wipe. So reduce that frequency. You don't need to clean as much, and you don't need to expose your stencil to as much abrasion as you did before. So reduce that frequency. So now we're going to get into a case study. We did this case study last year with Rowland. It was an excellent webinar, extremely informative. I'm going to go over it. I'm going to summarize it here in about 4 or 5 slides. But last year we did this full case study in a complete webinar. And if you find this interesting, I highly recommend that you go back to the NanoClear site. It's available for you to watch and download there. I would encourage you to go back and have a look because it's extremely informative. So Rowland utilized in their stencil printing improvement program a 3-pronged approach. They applied NanoClear to the existing stencils. Because there was no redesign of the stencils required, they did not need new stencils, so they used existing stencils. They were already in production. They also changed the solvent cleaner from IPA to a Zestron solution, and they changed their under stencil wipe to a microcare stencil wipe. We're going to focus mainly on their change to NanoClear in this topic today. Again, if you want more detail, I'd encourage you to go back and look at last year's webinar on our website. So some assumptions: they were wiping every 5 cycles, and they looked to improve to wiping every 25 cycles. They began implementation of these changes in April 2016 and completed by July of 2016 on all 4 lines. So starting, they were looking at an effective cycle time of 37 seconds per printed board, and they were hoping for or predicting an effective cycle time of 29 seconds per board. So essentially looking for a 22% improvement on their throughput after these changes were implemented. So let's see what they actually got in reality. So after the numbers were crunched, they found that they got a 35% increased production, which was very impressive. But what about the quality? Was it really possible for them to make it faster, cheaper, and also a better quality print? So let's look at that as well. So they found that between May 2016 and August 2016, their SMT defects were down 52%, and their ATE defects were down 42%. So I think that's an extremely strong case that not only did their throughput go up, but their quality also went up as well. So it was a great combination. So we're going to have another look at the cost savings calculator, so that we looked at earlier. And so you can see that Rowland determined that they were essentially paid back the cost of NanoClear after only 43 prints, and based on the cost savings after those 43 prints, which went to their bottom line, they found that they had an annual cost reduction of $400,000 per year based on these changes. This also led to increased production uptime of 52 hours per year, in addition to 4,680 additional PCBs assembled per year. So a huge improvements across the board with this activity. So in summary, NanoClear is the #1 nano coating globally for stencils. It's not just for fine pitch stencils. It's extremely easy to calculate the benefits of improved quality, boosted productivity, and reduced costs. It is proven to coat the aperture walls entirely and consistently, unlike other coatings on the market. And there are several techniques used to enhance the durability, such as soft wipes and less aggressive cleaners. NanoClear is available locally in Europe via CapLink, and it's also available globally via ASM or DEC. So now let's get into the Q&A session. Again, everybody's going to get a copy of this presentation. We're going to send out a PDF and a recording of the presentation itself. So that will be going out most likely tomorrow. So if you have questions in your control panel, please feel free to fill out any questions that you might have, and I'll get to them one by one in time. Okay, so the first question that's come through is, can I use NanoClear on a plastic stencil? And so we do get this question from time to time. Unfortunately, NanoClear is not compatible with plastic. It is only intended for use on metal stencils, so a stainless steel, a nickel stencil, or a an etched stencil as well. Another question has come through: do solvent-based stencil cleaners damage or remove NanoClear? So that's a great question. So by solvent-based, I assume you mean organic coatings, not aqueous-based coatings. Just to cover aqueous really quickly, aqueous-based cleaners are compatible as long as they're relatively neutral. So you would want to use something in the range of a pH between 5 and 9. With organic solvent-based cleaners, they're extremely compatible. We have years worth of data with this technology. We have numerous customers out there who utilize these coatings in other applications as well, with solvent-based coatings or with solvent-based cleaners. And no, a solvent-based cleaner in almost no circumstance will damage NanoClear. What we do find sometimes is that if the solvent is not cleaned off of the NanoClear, and the solvent is allowed to remain even in a very fine layer over the NanoClear, and you were to then go do a water droplet test, it might look like the efficacy of NanoClear is gone, but that just means the stencil has not been properly cleaned. But yeah, a solvent-based cleaner will almost never damage NanoClear. So next question that's come in is, do I need to use water after the cleaner? So NanoClear is a part A and part B paste treatment. So there's a cleaning step, a water rinse, and then the NanoClear is applied. So the cleaner contains salts which do need to be washed away. So you can't just use a water wipe, and you certainly cannot skip rinsing the cleaner off. It needs to be rinsed off with running water. So please be sure to rinse off the stencil with running water, allow it to dry, and then apply the NanoClear coating. Next question is, where can I get the NanoClear test pen? So the NanoClear test pen can be ordered along with your NanoClear order. Excuse me. If your supplier does not have it in stock, please just reach out to us. If you're currently buying NanoClear, we're certainly happy to help you with that order. Or if you're ordering NanoClear from us, we can certainly supply you with a NanoClear test pen with your order. The next question is, how long does NanoClear last? Okay, that's a great question as well, and the lifetime of NanoClear is certainly relative to how long NanoClear is utilized. So as long as you are using a soft under stencil wipe, you're using a pH neutral cleaner, then the NanoClear will not be damaged and will last a very significant amount of time. So we find that users who are using recommended practices will see that they get 25,000 to 50,000 prints out of the NanoClear. Another question that's come through: does solder paste damage or remove NanoClear from the stencil aperture walls? That's an excellent question. And as you saw when you went back, we showed the TEM slides where we did the cross-section of the aperture wall before and after 15,000 prints. So that was 15,000 prints from solder paste flowing through the aperture wall. and you can still see that the NanoClear coating is intact on the surface. So no, via SEM cross-sectioning, we can prove that the NanoClear is still present on the aperture wall. So no, solder paste will not damage the coating in the aperture wall after 15,000 prints is the quantified study we did. So if there are any other questions, please enter them. I'll give it about another minute or so. But that is looking like it's wrapping up the questions for now. So any other questions, please get them in and I'll answer them. Otherwise, if I don't have anything in the next minute or two, I'll wrap up the presentation. Another question came through: is it possible to use NanoClear on nickel stencils? So yeah, the NanoClear treatment is designed for use on any metal. So it'll bond with any metal you use it on, except for titanium and aluminum. Not that there are stencils in titanium or aluminum, but theoretically, those are the only two stencils you couldn't use it on without a cure. Otherwise, NanoClear is applicable on any metal that you wanted to treat. Next question is, how many stencil washing cycles can the coating withstand? And that's a great question. So that depends on the coating wash that you're using. So if you are using a non-aggressive wash cleaner, then the coating wash will not destroy the NanoClear. If you're using an aggressive or a high pH cleaner, then you could potentially have issues. And then how many prints and wipes can the coating withstand? Again, is addressed based on the type of cleaner you're using and the type of under stencil wipe. If you're using an aggressive cleaner and an aggressive under stencil wipe, then you might have longevity issues. You may have to reapply it after 5,000 to 10,000 wipes, or prints, I should say. But if you're using a non-aggressive cleaner and a non-aggressive wipe, then you're not going to see issues, and you should potentially hope to get a lifetime of treatment out of that treatment on your stencil, up to 25,000, 50,000 prints. Okay, any other questions? Okay, so with that, I appreciate the questions. Thank you for attending. We'll be sending out a follow-up email to all the attendees with the PDF and the recording of the webinar. And with that, thank you very much for attending. You'll be getting information from us shortly. My email is on the screen as well, so if you have any questions, please feel free to reach out.